Well, hi everyone, this is Bob the Science Guy, and we're continuing our homework of Chapter 1 in University Physics 1. Now, in this section, we're going to look at dimensions. The long and the short of it is pretty simple. If you want an answer in apples, does the equation spit out apples, or does it spit out grapes? So, let's get right into it. Now, our first question is going to be number 51. Consider the physical qualities, distance, velocity, acceleration, and time with dimensions right there. Determine whether or not each of the following equations is dimensionally consistent. If the answer is in apples, does the equation spit out apples? So let's go ahead and write a few things down. Okay, so here's problem number 51, and it gives us these four values right here. Okay, S equals L, velocity equals L over t, acceleration equals L over t squared, and t, of course, equals t. And then it asks us whether or not these equations are consistent with each other. So we've got v squared equals 2as. Okay. Now, what do these units actually represent? Well, v equals L over t. Okay. 2 is a constant. We don't even need to worry about that. A is L over t squared, and s is L. Now, because v is squared, both of these are squared as well. So what do we have here? We have L squared over t squared equals L times L is L squared over t squared. Those are the same thing. They're consistent. Let's look at B. Now the equation for B is S equals Vt squared plus 0.5 at squared. Okay? What's S? S is L. What's V? V is L over t. T squared is t squared. Plus, don't need to worry about the 5, or the 0.5. So we've got L over t squared here times t squared. These cancel. One of these will cancel. And we end up with L equals LT plus L. There's an extra term in here. This gives you length. This gives you length times time. Okay, so they are not consistent. L does not equal that. And the last two are pretty straightforward. Do you know what velocity is? Well, yeah, it's right there. V equals S over t, so LT equals LT. It's consistent. Acceleration equals velocity over time. Is that consistent? Well, acceleration is L over t squared. Velocity is L over t. And it's multiplied by 1 over t. So that's L over t squared. They are the same and they are consistent. Now there's actually a couple of problems left, and they deal with significant figures and scientific notation. We've kind of been through that in the initial episode, but I'll just run through these real quick at the end of this episode, and then we're all done with Chapter 1. So let's just hit it. Okay, problem number 66 gives us this equation. All right, so we've got 4,000 divided by 400 equals 10.0. Okay, this is very important right here. Because under the rules of significant digits or significant figures, your answer can have no more significant figures than the least amount of significant figures on the other side of your equation. Now, this 0 is significant, and as a result, it equals 3 significant figures. The reason this 0 is significant, whereas that one may not be, is because of the placement of this decimal place. Any numbers, any zeros to the right of the decimal place are considered significant. What does that say about 4,400? Well, in order for this to be 3 significant figures, these, at a minimum, have got to be 3 significant figures as well, which means that all of those are significant figures. You would not normally say that just looking at it, but the fact that they report it out like that implies that all 3 of those are significant. Okay? Could we have 4 significant figures here or 3? It really doesn't matter. Whether this last 0 is significant or not, this has to have at least 3 significant figures in order to report out 4 significant figures. That's kind of a tricky question. Now the next one is number 68. Now 68 says, as you can read, that a good quality measuring tape can be off by 1/2 centimeter with two significant figures, two numbers to the right of the decimal place, over a distance of 20 meters. Now, how do we figure out the error here? Well, first of all, we need to convert all of these to the correct form as far as scientific notation goes. So this is going to be 5 times 10 to the what? Well, centimeters are 10 to the negative 2, but that's not a full centimeter, it's 1/2 centimeter, so 10 to the negative 3 meters over 20 meters. Actually 2 times 10 to the 1 meters. Okay, so that's our correct scientific notation. Now, what is our answer? There's two parts to this, okay? The part here will give us our number. So 5 divided by 2 equals 2.5. And then we have to figure out our magnitude. That's the character in the mantissa. We need to figure out the magnitude now. So how do we figure out the magnitude? Well, we take negative 3, and since we're dividing it by 10 to the 1, we have to subtract it. So that will be 10 to the 4. Okay, but we're not quite done yet, because this has to be given in percentages. So we've got 2.5 times 10 to the negative 4 is our raw number. We multiply that by 100, 10 to the 2, to get our percentage. And as a result, our answer is 2.5 times 10 to the negative 2%. And that's our answer. The number of significant figures in the following measurements. Okay, so let's go ahead and do that. And ladies and gents, that's all she wrote for Chapter 1 homework. So this is Bob the Science Guy. Stand by for Chapter 2. We'll start off with a quick review of trigonometry and vectors. So until then, take care.